let us see the variation of the shape functions n1, n2, n3. So let us begin with node 1. At this node we know that zeta is -1. So substituting in these equations n1, n2, n3, we get n1 equals to -12 -1 1 into -1, which is 1. Okay, similarly n2 after substituting will get as 0, and in n3 will get as 0. To draw this variation, so we know that this is node 1, this is node 2, and this is node 3. At 1 the value is 1, at node 2 it is 0, and at node 3 as well it is 0. Okay, this is node 2 and this is node 3, so it is 0. The equation that we have taken is alpha 1 plus alpha 2 zeta plus alpha 3 zeta square. So the variation will not be linear, but it will be parabolic like this. The same we have to do for node 2. So at node 2 we know that zeta equals to 0. Substituting the value, we will get n1 0, n2 as 1, and n3 as 0. So here it is node 1, this is node 3, and this is node 2. So we have 1 and we have 0 and 0. Okay, so this was the variation of n1, this is the variation of n2, and lastly at node 3, at node 1 this was +1, this was +1. At node 3 zeta is 0. So here after substituting we get n1 0, n2 0, and n3 as 1. Node 1, 3 and 2. And here it is 0 and 0. Node 3 is called as an internal node, and the mapping of the general coordinate system x and the coordinate system zeta, the local coordinate system, is given by 2 into x minus x3 upon x2 minus x1. So the conversion from natural coordinate system, zeta is natural coordinate system, and this is the general coordinate system, is given by this formula. The displacement field within the element can be given as n1 q1 plus n2 q2 plus n3 q3. If you are given a 3-noded bar element with 3 nodes 1, 2 and 3, and you are asked to find out the displacement somewhere between these nodes, then you are going to use this formula. This is for a 3-noded bar element. So the n vector can be given as n1, n2, n3. Okay, and it is a 1 by 3 vector of the shape functions, and q can be given as q1, q2, q3. Okay, so q can be written as n into q, where n is this vector and q is this vector. Let us take a problem based on what we have just solved, or a two noded bar element. You are given a bar element like this. X1 is given as 20 inches, x2 coordinate is 36. You need to find out at a point P which has the coordinate 24 inches, you need to find out the displacement at that point. Okay, there are two parts of the problem. One is to evaluate the natural coordinate, that is zeta, at the point P and n1, n2. Second, you are given q1 equals to 0.003 inches and q2 equals to minus 0.005 inches. Determine displacement at P. The length of this bar element can be given as x2 minus x1. So it is 36 minus 20, which is 16 inches. For part A, we need to find out the value of zeta. Zeta in terms of x is given as 2 by L, x minus x1 minus L by 2. Substituting the values of L, x, x1, we get zeta as minus 0.5. There are no units. Next, we are asked to find out what is n1 and n2. Now, for a two noded element, n1 is given by 1 minus zeta by 2, 1 minus of minus 0.5 by 2, which is 0.75, and n2 is 1 plus zeta by 2, so we've solved the first part of the question. The second part of the question, we are asked to find out the displacement. So we are going to use q equals to n1 q1 plus n2 q2. We know the values of n1 and n2. We also know the values of q1 and q2. So the displacement at P is 0.001 inch.